Yeah, anyways, hello, everybody. My name is Nico Spadafora. I'm a paleontologist here at the fossil team. And I'm getting back feed on my my end here with the sound. But yeah, I'm with the fossil team. I study dinosaurs and extinct mammals like saber-toothed cats and mammoths and stuff like that. And yeah, I guess what we're looking at right now is a parrot, which is a dinosaur. And yes, I see Nico. Yes, Nico is my name. Nico. Um. So yeah. Heckin' love saber-toothed cats. Me too. Yeah, I do love me a good saber-toothed cat. Right now I am preparing for a good science festival here in Oregon. I'm based out in Oregon here, and my saber-toothed cat skull is currently packed up in a box so that I can bring it to said festival. So my office is looking pretty empty right now of fossils, but yeah. Is Stompy the name of the parrot? I'm gonna assume yes. Stompy is a pretty cool dinosaur. I'm looking at that dinosaur right now. Yeah, birds are dinosaurs, in case you didn't know. There is the oh, Stompy is the emu. Okay. Very cool. I do love emus. Emus are fascinating animals, and there's a whole family of dinosaurs called the ornithomimosaurs, the bird mimics, and one of them, Struthiomimus, not quite an emu, but Struthiomimus quite literally translates to ostrich mimic, and the ornithomimosaurs are really interesting because they do look a lot like ostriches and emus, just with the long tail. Still, they were about the same size, maybe a little bigger. And yeah, they're awesome. Well, hold on, I'm reading this question. What do we know about the sounds that dinosaurs would make? You know, that is a great question. We don't actually know. There's some theories, and I see you're bringing up the T-Rex sound there as well. Darkrow, that's a cool name. We don't actually know the sounds that dinosaurs would make. The idea behind that Tyrannosaurus sound is based on looking at modern dinosaurs and their you know, the birds, and their voice boxes, their vocal cords and all that. And
Bloody Becca resubbed for 3 months. Bird.
Reconstructing what we think they would look like inside the, you know, the throat of a tyrannosaur or any other dinosaur. And so you know, these sounds that are coming out in those videos are really good guesses, but we don't know for sure what the dinosaur would have sounded like. However, if you look at hadrosaurs, which are, you know, the crested lizards like Parasaurolophus and Corythosaurus, those big horns on their heads are directly connected to the nasal cavities and probably would have impacted sound in some way, creating these deep, resonating, honking sounds. Trying to think of a modern reference for what they could have sounded. I don't know, maybe, you know, a clown horn, I guess. I don't know. They're funny and very interesting. And yes, emus are silly, and dinosaurs definitely could have been silly back then too. I think there is this, you know, with, you know, I make the joke about Jurassic Park at the beginning of the segment here for me, I guess. But there's this kind of idea that dinosaurs were just stomping around killing each other all the time, but I'm sure they were doing a bunch of goofy, silly things. They were the dominant species for sure, so they could, you know, do whatever they wanted.
People Pug, wow.
Sharp_easy resubbed for 9 months. Jurassic Park theme.
Ooh, were dinosaurs worldwide, or were they like only specific yeah, that's a great question. Actually, dinosaurs were. We have fossils from every continent on the planet, including Antarctica. There's a really cool species of theropod, that's one of the meat-eating dinosaurs, called Cryolophosaurus. It means frozen crested lizard. And that was discovered in Antarctica. We've got dinosaurs from Australia. Obviously, you know, North America with T-Rex and Triceratops and stuff. We got Asian dinosaurs. There's a really cool, fascinating bunch of dinosaurs in Madagascar that are kind of separated from the rest of the planet that look really interesting. And I can get into that in a second. But there's also in Europe, the continent that, you know, we call Europe today was mostly underwater in the age of dinosaurs and was more of a big island ecosystem. It was a bunch of islands put together. And one of those island segments they call the Hatseg Island environment. And there, these dinosaurs, we didn't have any big carnivores. There were no tyrannosaurs, there were no carnosaurs. And then there was a third family in the Cretaceous period that's kind of the bigger meat-eating dinosaurs, the Abelisaurs, things like Carnotaurus and Majungasaurus, if you know that one. That would be the Madagascar species, Majungasaurus. None of those seem to be in those environments. And on top of that, the herbivores in those environments seem to be it gave us when they were first being discovered, this started the theory of the island dwarfism effect. And so you have things like Magyarosaurus, which is a species of sauropod, one of the long-necked dinosaurs, known for being huge. And Magyarosaurus is about the size of a cow. We've also got Telmatosaurus, a species of hadrosaur or hadrosauriform that is also really tiny. And on top of that, because there's the lack of giant predators, the animals that kind of evolved to take place as those predators were things like the raptor dinosaurs, dromaeosaurs, and, well, birds, actually. There's kind of an in-between family of birds, the avali. And one of my favorite dinosaurs altogether, this dinosaur called Belauer Bondoc. Kind of about the size of a real velociraptor, not a Jurassic Park velociraptor, but Belauer was a really interesting looking. The debate is out whether it was more of a dromaeosaur or if it was more of a bird, but Belauer stands out in my eyes because the killing claw, which raptors are famous for, all raptors have one on each foot, but Belauer had two killing claws on each foot, which is really cool. And then on top of that, there was also the giant Asdarchid pterosaurs like Hatzegopteryx. They were giraffe-sized and flying around eating everything. See, I got to catch up on the chat. I got too into my talk there. Ooh, I scrolled back, and how did the Bezel bufo get discovered? That's a great question. I'm actually not super familiar. I know the species Bezel bufo, the giant devil toad from Madagascar, but I have not looked into the species very much. I'm not super familiar with how it was discovered and the size ratios of it. I do know it was a pretty big frog, and it would have eaten things like baby dinosaurs, but I don't think it was much big. You know, I'm trying to think. Was it dinner plate sized? I'm gonna have to look that one up. I'm not super familiar with Beelzebufo, Bufo, so I apologize for that. All right, catching back up here. Thanks. So I heard that some dinosaurs also swallowed stones to help with digestion. Do we know where this behavior first appeared? It is true. There are dinosaurs that swallowed stones. Gastroliths is what we call those. The sauropods and most of the older families of dinosaurs would have swallowed stones. They would do this because dinosaurs didn't chew their food. Chewing didn't really evolve in dinosaurs until the end of the Cretaceous period with the hadrosaurs and ceratopsians, the horned dinosaurs. So things like Brachiosaurus and the Titanosaurs, and I mean Magyarosaurus too, like we were just talking about, and a lot of those dinosaurs would Stegosaurus and Ankylosaurs, they would have swallowed stones to help grind up the plants inside their stomachs. And their teeth would have been shaped more for picking things rather than grinding things up. That's why when you look at pictures of sauropods and they look like they have sharp teeth, it's because they have rounded spoon-shaped teeth. Literally, actually, I'm looking at, on my desk here, I have the tooth of a Camarasaurus, which is a Jurassic dinosaur that had these spoon-shaped teeth. Very interesting looking. But the gastroliths, when did they appear? That's another one I'm not super confident on the answer for. But knowing that they was so so ingrained in their biology to swallow stones, and it wasn't just plant eaters. We know that things like plesiosaurs, which aren't dinosaurs, they're marine reptiles, the long neck, Loch Ness monster looking things that lived in the water, they swallowed stones to help grind up food as well. This would have appeared really early on, probably way back before they were truly dinosaurs. Back in their they're not archaic, archosaur, dinosauromorph forms, and probably even before that, chewing was a very, very new tool. And really, the first things to chew before the dinosaurs were, in fact, the mammals, because we were, I say we, but mammals altogether were insectivores, and they would have had to chew up their buggy foods. All right, catching up again. What's the newest dino fact you most recently? So what's the newest dino fact I most recently learned? Ooh, that's a tough one. But to kind of answer the second part of how curious how knowledge is expanding, it simply comes down to reading papers that come out and talking to other paleontologists who read papers before you. And my job, truly, so as a paleontologist, I tend to focus more on the education side. And so my job is mainly in science communication rather than going out and digging up dinosaurs. I've done a couple of digs, but most of my career is in education and talking to folks. And so most of the time it's sitting there and talking to other people about what they're learning and vice versa, what we're learning and sharing info with them. My job is really to take those scientific papers that, I mean, I don't know how into it you guys tend to get, but at least with the people I tend to work with, it's taking those papers, which can be really hard to read, even for me sometimes, which actually isn't saying a lot. I sometimes I barely speak English, I feel, but taking those papers and making it more digestible for the general public. Hence why the science festival that's coming up this weekend, I'll be giving some lectures and setting up a booth looking at dinosaur bones and mammal bones and such. But most recent dinosaur fact I learned. I went to a really interesting lecture by this other paleontologist by the name of Dr. Jingmei O'Connor. and she specializes in the dinosaur to bird transition. And she works at the Field Museum in Chicago and was recently looking at the new Archaeopteryx specimen that came in. And that specimen shows a lot of new things about the animal and helps us really understand bird evolution. Archaeopteryx right now is currently recognized as the first bird. It's the oldest bird, true bird in the fossil record. This could lead into a whole other discussion, but it's already very bird-like, minus the fact that it has the long dinosaur tail still. It's pretty much a bird. It could fly, it did all the bird things. And so what is odd about this new fossil is we see this new morphology in the mouth that matches up with birds today, and shows that this was yet another bit of bird evolution that was already super ingrained into their evolution. And so with Archaeopteryx having this, and I'm not sure I can say the exact thing it is yet. I believe, well, okay, maybe I can. So imagine you look inside a bird's mouth, and even like other reptiles, think like a leatherback sea turtle, and you see all those barbs and weird stringy fingery bits to help hold jellyfish and other things down. Archaeopteryx had that in its mouth, which is really interesting. And because Archaeopteryx had that in the Jurassic period, that might mean that dinosaurs like Velociraptor and T-Rex might have also had those weird stringy bits in their mouths as well, making them far more terrifying than they already are. Yeah, Stompy's granduncle. So yeah, I guess that would be the most recent thing I learned from other paleontologists. Dinosaur fact is more bird stuff, and just how bird-like or dinosaur-like birds are. A lot of features you would look at a bird, like take the emu here, for example, Stompy. A lot of the features you see that we would associate as a bird characteristic showed up in dinosaurs first, like the three-toed feet and the scaly legs and the bobbin of the head and the feathers. Even like all of that, those are dinosaur traits. Those are not specific to birds. Things that, because we see birds, we don't see living tyrannosaurs and dromaeosaurs and ceratopsians today. We see just the birds. And so a lot of these features are dinosaur features, and dinosaurs very likely had a lot of them too. Probably drank water the same way Stompy does. How did the hummingbird originate from dinosaurs? That is a fantastic question. Hummingbirds are fascinating. I believe the first hummingbird, like what we would call a hummingbird today, showed up actually in the Cenozoic era, which is the age of mammals. But I like to, especially when I'm teaching my classes, one of the things I really like to say with helping people understand evolution is that evolution, I like to say that evolution is lazy. Evolution reuses designs. And a really good example of this is actually if you look at modern animals and you look at the thylacine, the Tasmanian tiger or Tasmanian wolf. In the environment in Australia, there was a need for a predator, a pursuit predator that would chase things. And dogs are kind of built for doing that. And the environment needed that animal, that something like that animal, and so it created it out of what it had. It had marsupials, it had possums and koalas and stuff like that. And they made a wolf out of a possum, and now you have thylacines, right? And now those thylacines are gone, unfortunately. But that's that's how it goes. And so, yeah, rest in peace, thylacine. And that's not even the only example of Australian megafauna that did that. And another one, the marsupial lion, Thylacoleo, another very awesome animal that basically same thing, but replaced dog with cat. There was a need for a cat-like animal in the environment, and so the environment created one with the Thylacoleo and other marsupial lion relatives. And that one is actually a diprotodont, which means its most closest living relatives are koalas and wombats. So they made a lion out of a koala. But anyways, getting back to the hummingbirds, I believe hummingbirds showed up in the oh gosh, it's either the Miocene or the Oligocene, I believe. I'm gonna have to double check that one. But before, in the age of dinosaurs, in the Mesozoic era, we actually have this really cool fossil where a hummingbird-like animal, hummingbird-like dinosaur, got its head stuck in tree sap, and the tree sap hardened, and the animal died, and it fossilized. It preserved the head, and we were able to find that fossil. And it shows alarming detail. That animal looks just like a hummingbird. I got to remember what its name is, though. Let me double check it, because I'm sure you guys are going to look it up as soon as I say it. Let me pull up my interwebs here. Probably maybe here it is. Looks like a hummingbird. It is called Oculudentavis. Oculudentavis. Spelled Oculudentavis. Hummingbird-like, except it still had teeth. So it was probably not eating like a hummingbird, but it was definitely flying around like one. Was the island dwarfism phenomenon common, or were the land masses connected enough that it was relatively rare? So kind of the same idea with what we were just talking about. Island dwarfism happens all the time. We see it today. We also see island gigantism in the case of like the moa and the elephant bird. But in the case of the dinosaurs, it was island dwarfism, probably because, you know, there was so many dinosaurs and not enough food, and so shrinking in size helped preserve those food resources for those animals. But yeah, island dwarfism happens a lot, and we see it today as well. We see it before the dinosaurs, but these dinosaurs, when they were discovered, were kind of the catalyst to helping us understand that idea, that phenomenon. Ooh, do you see dinosaurs in modern birds more or in reptiles? You know, personally, as a dinosaur nerd, in birds, because I know they're dinosaurs. I look at that and I go, look at those dinosaurs. I have chickens and ducks in my yard, and whenever I go to feed them, I'm like, here you go, you stinky dinosaurs, and they love their feed. But in reptiles, there's only one line of reptiles today that's related to dinosaurs, and it's not the Tuatara. That comes up a lot. Tuataras are very, very a very old lineage of squamates, the lizard and snake family, and they're the only ones left of their kind, but they are not dinosaurs. The closest thing living to dinosaurs today, other than birds, other than Stompy the emu there, would be crocodiles and alligators. They are part of the same family, a crown group, we should say, called the archosaurs. And with the archosaurs, there's kind of like a three-way split. One way, really early on, you get the pterosaurs. The pterosaurs break off before crocodiles and dinosaurs. And then way after that, you get another split with crocodiles and dinosaurs. And crocodiles actually at the beginning of the age of the commonly called age of dinosaurs, the Mesozoic era. So in the Triassic period, crocodiles were actually the dominant land predators. You had things like the Pseudosuchians and the Rauisuchians. If you have ever seen Walking with Dinosaurs, that would be Pastasuchus and Saurosuchus and stuff like that. And those animals were basically in charge, and they kept dinosaurs pretty small. But with the Permian extinction, the Permian is the age right before the Triassic period. It's the end of the Paleozoic era. With the extinction of the Permian, there was a big aridification of the planet, and while they were successful for a little bit, they couldn't quite keep up with the aridification. And dinosaurs, which were warm-blooded animals, were able to do that and keep up and find food and get all these places where crocodiles couldn't, and eventually outcompeted those animals and became the dominant species. So I do see it a little bit in crocodiles, but not as much as I do in birds. Birds are dinosaurs, therefore I see them. And you should too. Do you know any Saurosuchian dinosaurs that were actually tree climbers and that actually jumped incredibly high? Or is that fiction from video games? That's a great question. Saurosuchian. Well, we do have tree climbing dinosaurs. I don't know about crocodiles. We might have. We had galloping crocodiles and land-based crocodiles and stuff like that. I would not be surprised if there was a couple of crocodilian ancestors that were small and were climbing trees. But none are coming to mind right now that I can think of. Interesting. That's a good question. Oh, yes, we got the Beelzebufo on the screen now. Is the modern mosquito fern the same one that caused an ice age back then? Mosquito fern? I don't think I've ever heard that. I don't think ferns caused ice ages altogether. That was a climate shift due to carbon dioxide and volcanoes and the growing of the Himalayas and stuff like that. When was Titanoboa around? Ooh, Titanoboa would have never seen a dinosaur. But Titanoboa almost did. Titanoboa shows up right after the age of dinosaurs in an era we call the Paleocene, which is the first part of the Cenozoic era. And the Paleocene, it was kind of a similar thing with, crocodiles in the Triassic period, when mammals were still kind of figuring things out and expanding and diversifying in diets and sizes and all that. The birds were able to get big for a little bit, and dinosaurs almost took over again with the start of the terror birds. We have things like Gastornis. But then there was also crocodiles. The crocodiles did survive the extinction. None of the land-based ones did, but we still had things like Borealosuchus, which was a Cretaceous crocodile. Would have looked pretty similar to the crocodiles we have today. And that thing was a moderately large-sized crocodile, standard crocodile size today. That would have eaten all the mammals. But then you did have things like Titanoboa, which were the longest snakes ever. Titanoboa, I believe, was 43 feet long, if I'm remembering off the top of my head, which is massive. That's huge for a snake. The mosquito fern is the Azola event. That's the name. Oh, interesting. I've never heard it called that. I'll have to look into that. I'm going to be teaching a class on the Pliocene here in a little bit. couple of days, actually. Interesting. My dad is on a conspiracy kick that says dinosaurs were big because Earth's gravity was lower. That's not the case. Gravity was the same. Dinosaurs got big because their bodies allowed them to get that big. They have different metabolisms and different ways that their bodies work than mammals do, and so that allowed them to get as large as they did. And also, their bones were hollow, and this includes the big sauropods. They have these like kind of honeycomb like structures in their bones that made them light, but strong and powerful, and so that allowed large dinosaurs to get that large without gaining too much weight. Even though we still look at things like titanosaurs, like Argentinosaurus, which are still 110 feet long and like 40 to 50 tons or something like that. But no, the gravity was pretty much the same. When I was growing up, Dimetrodons were mammal-like reptiles. Now I see they're called stem mammals. Do you know where these stem mammals fall on the evolutionary path and what discoveries made the shift from mammal-like reptiles? So mammal-like reptile is a TV term, right? That's kind of what TV calls them. I don't think scientists ever did call them that. Before we didn't really know what to call them, but before we had the name stem mammal. But we knew they had something to do with the mammals, especially when you look at things like Dimetrodon. Kind of the big thing that separates, I mean, if, looking at the animals from the outside, looking at with the skin on and stuff like that, the big thing that would separate things like Dimetrodon from dinosaurs is looking at the teeth, how the teeth are structured and placed in the mouth. And Dimetrodon starts to show that the configuration of teeth that we have now, your incisors, canines, molars, and premolars, right? Whereas dinosaurs and other animals that are not in the other line I'll mention in a second, they don't. They are not heterodont, is what we call that, different toothed, right? They have one kind of tooth throughout their entire mouths. They replace them throughout their lives, like sharks, and they don't vary in shapes, but they might vary in size, depending on how quickly the tooth in front of it falls out, right? And that's why you get the snaggletooth T-Rex look and stuff like that. But Dimetrodon and synapsids like us, we are all synapsids, and so is Dimetrodon. That's the family we're in, the synapsids, whereas dinosaurs and birds and crocodiles and reptiles and stuff, they're all part of another family called diapsids. And that's when you look inside the animal and you look at the skull, and it's basically diapsids have an extra hole in their skull, whereas synapsids don't. And synapsids actually, modern synapsids, a lot of us have actually lost one of those other holes. So really, we just kind of see the eye hole, the eye hole and the zygomatic arch hole. Whereas there's another hole in the top of the head for diapsids. Their heads are a bunch of different pieces put together, whereas our skulls tend to fuse together as one big piece. And so, yeah, to kind of answer the question there, the stem mammal, where on the evolutionary line do they line up? They separated from diapsids and other, what would eventually become the dinosaurs and stuff like that, long before dinosaurs and archosaurs were even in the question, right? They were still forming, and stem mammals were already there. Mammals split a long time ago, but when they truly became mammals, when they officially became mammals, we believe is about 225 million years ago, which would be the Triassic period, age of dinosaurs, right? Things like Morganucodon and stuff like that. So yeah, I think that answers that question. Why do these dinosaurs like hugs so much? Have you been hugged? Because I think hugs are pretty great. Have I ever licked a fossil? Yes, that's how you tell it's a fossil. If you lick dinosaur bone, because of the hollow nature of it, your tongue will stick to it. Oh, yeah, I saw Stompy Stompy's still getting a hug. I love that. I'd hug an emu. Oh, chat, you should get hugs. Unfortunately, tyrannosaurs can't hug. Their arms are too short. But there's dinosaurs with shorter arms, the abelisaurs, like we brought them up earlier, Carnotaurus and such. Their arms were actually vestigial. We make fun of tyrannosaurs and T-Rex a lot all the time because you know, they're the famous dinosaurs to talk about, but their arms were actually incredibly muscular. If you look at the muscle attachments on the bone, they had a lot of muscle on those small arms, so they were using them for something. And you know, theories go all over the place with it, but they were definitely using them for something. Whereas Carnotaurus and other abelisaurs, their arms were vestigial, their fingers were shrinking back, and you know, assuming that evolution was allowed to continue with those lines of animals, their arms probably would have disappeared altogether. Ooh, okay. Couple of questions popped up. So what are the legalities of finding and owning fossils in the US? The general rule is that if it is an invertebrate, so things like bugs and cephalopods and stuff like that, or mollusks and whatnot, those don't, there's no regulations on finding those and keeping those. If you go out and dig and you find those, you can keep those. It's like rock hounding, right? But vertebrate fossils, mammals, dinosaurs, things with a backbone, there are laws and regulations on them, and generally you're not supposed to keep them, especially if it's on public land. If you find a fossil, generally you're supposed to report it to the, you know, the land bureau, and then they will contact whatever close museum or research lab that they want, and they'll go out and dig it up. And a lot of times there will be volunteer opportunities, and so you can go and join them with the dig, right? But in the case of private land, and this has been popping up a lot, unfortunately, with the current auctioning off of dinosaur fossils, and it happened with Sue, the Tyrannosaurus. That's the big Tyrannosaur at the Field Museum. If it's found on private land, that animal is technically owned by that land owner, right? And so they can do whatever they want with it. And most of the time, these landowners, a lot of the other paleontologists I know and work with who do go out and dig, a lot of the times the landowner owners are super cool, and they're like, oh yeah, I found this dinosaur, come dig it up, and when you're done you can have it. I've got nothing to do with it. But with this increase in auctioning off of these skeletons, like the big apex, I think the apex was the name of it, but the big stegosaurus that was just auctioned off for, I think, $44 million. And then a couple years ago, Stan the Tyrannosaurus was auctioned off for $31.6 million. That's going to start creating this idea that you can make money off of your dinosaurs, and that's going to start to, you know, damage science, because there's going to be a lot of dinosaurs that don't get into, you know, the science eye for people to study and learn about how these things evolved and moved around. And that goes for mammoths and saber-toothed cats as well. So there is the potential of buying them, I guess, but really fossils are for everyone, right? Oh, hold on, I'm trying to get back to where the questions were. Will you turn into a dinosaur now that you've licked a fossil? I hope. I'd love to be a dinosaur. I'd love the, you know, the Spider-Man thing. That'd be awesome. What do you wish the general public understood more about dinosaurs? You know, I guess there's a lot, but at the same time, the wonder that dinosaurs create, that's kind of what I'm here for. You know, the dinosaur, I like to say that dinosaurs are well, for lack of better words, they're a gateway drug, right? Dinosaurs are what get people into science. Dinosaurs are what get people into learning about evolution and how the world works, right? And so really, I don't care what the general public knows, as long as there's an interest and a willingness to learn about them, then they can, you know, be into whatever they want. You know, I mean, it does bug me that they focused so highly on the Tyrannosaurus arms and how they're so small, but like, I already told you a cool fact about them. So I guess maybe the Tyrannosaurus arms, because I'm tired of those jokes. Do paleontologists get hugs? The silence says everything. Yeah, we get hugs. Nico, how about brain size relative body size? Where are dinosaurs, any era, as smart as, say, corvids? That is a fantastic question. There's this fantastic dinosaur book out there called The Rise and Fall of Dinosaurs by Steve Brusati, and he talks about this study called the encephalization quotient. And that is a really interesting study. It's you know, debated, as with every scientific thing out there. There's people who disagree with the idea. But if that were the case, if this is, you know, if the brain to body size ratio is an accurate thing with, and you know, the I should say, before I say this, the encephalization quote applies specifically to mammals and dinosaurs, not necessarily to cephalopods or bugs or whatnot, right? It's these larger brained animals. The tyrannosaurs seem to be really, really smart. And unlike the movies, the dromaeosaurs seem to be very, very not smart, unfortunately. And fortunately, I guess, depends on how you look at it. But yeah, the tyrannosaurs seem to be incredibly smart animals. And according to him, he was saying corvid to primate intelligence in tyrannosaurs. There was a paper that I recently read that kind of disputed this theory because somebody took that a step farther and was saying that Tyrannosaurus in particular would use tools. And this led to this whole fight after this paper, and with a bunch of other paleontologists and biologists and stuff. And the idea that Tyrannosaurus could have used tools would be a cool thought in theory, but I doubt it. And I think there's also a misuse of the term tool use, because when you hear tool use a lot used in terms like this, that often means to those people also like tool manipulation and tool creation, right? I don't think tyrannosaurs are creating spears and cars and taxes, right? But they are, well, I shouldn't say they are. They could pick up a stick, I guess, but that's not tool manipulation, right? So there's a lot of things, and the encephalization quotient is a really cool theory. And I think if it were proven to be the case, and it does seem to be pretty accurate because it lines up pretty well with what we know about mammals as well, and corvids, actually. Corvids got a pretty good encephalization quotient rating. So it could be the case. I'm not entirely sure. The other thing to note about brains is their brains are not shaped the same way mammal brains are, right? Dinosaur brains still tend to be very, very tube-like, right? And if we look at T-Rex in particular, since we were talking about tyrannosaurs, a lot of that brain size is devoted to the smell and sight of the animal, which would make sense because it's a predator, right? And so not a whole lot. A lot of the intelligence we associate, especially even with corvids and stuff, is in the front of the brain, right? Not the sense organs. Dinosaurs are the coolest animals that have ever walked the earth. Yeah, I tend to agree with you there. Although I'm kind of a mammal fan. I do love me a good mammal. Let's see. I'm trying to catch back up. Let's see. Could not have. There's a question. I want to make sure I'm getting everybody's questions here. Man, everybody's loving Stompy. That's good because I love Stompy too. Let's see. Next question was, is it true that dinosaurs could not have had scales and could have had feathers or fur instead? So that is a whole can of worms. And the debate is still out, but the debate is not whether they had scales or feathers. The debate is which ones had scales or feathers. With a lot of theropods, the meat-eating dinosaurs, we know for a fact that most of them had feathers, even T-Rex. However, when you say that to, say, the general public, right? As soon as you say like T-Rex had feathers, suddenly people are imagining a big chicken with teeth, right? That's not the case. That's not the case. Feathers evolved in dinosaurs as a form of temperature manipulate or temperature retention, kind of like mammals have fur. And the first feathers, these proto feathers, would have looked more like hair. And so there's a really cool TV show out there. The heck is going on? Sorry, my cats. I'm in my office and my cats have decided to show up and cause ruckus. Speaking of mammals. The cool show, Prehistoric Planet. If you look at the T-Rex in that show, that T-Rex, if you look close at the skin, which looks really scaly from a ways back, you look closer and you see these little hairs. It looks like elephant skin. That's probably what we're looking at with things like T-Rex, because T-Rex would have lived in a very tropical environment. And with that, the other dinosaurs that would have been in more northern environments, things like Nanuqsaurus, which means polar bear lizard, would have had more coating of those proto feathers, which would have given it a hairy, shaggy look, right? But they were feathers. They weren't hair. They were feathers. They just would have functioned more like hair. The feathers that we think of when we hear about feathers, like on birds and stuff, evolved later down the line as these animals started to manipulate their hair-like feathers more to use as a display tool, to show off, to attract mates or scare away predators or whatnot. And the feathers eventually would have spread out so much that these feathers would have eventually started to catch lift, and then boom, you've got flight, right? So yeah, the question, the debate is whether things like ceratopsians had a feather coating, right? They would have gone down the other line that birds were not a part of. Things like stegosaurs and ankylosaurs, did they have a furry coating, right? Some people like to imagine ceratopsians like Pachyrhinosaurus, which is a more northern species, to have a coating of hair because it would have lived potentially in cooler environments. But we don't know because we don't have a lot of these animals represented with feathers, right? The thing about theropods is we have a lot of these animals preserved in a way that saves those feathers, right? Whereas we don't really have that with the ceratopsians and bigger things. Same with sauropods, hairy sauropods. Megalodon isn't real. That's what everyone should know. Well, I guess, you know what? We're going to play on that. Megalodon is real. It's a real animal. They are no longer around. That's what people should know. The idea that they're hiding in the trenches deep down in the like the Mariana Trench and stuff like that, that's just not the case. The reason they got so big was because they lived in warm seas, and they went extinct because the seas started to cool down. The fact that they're hiding in cooler places is just not the case. They're not around anymore, but they were real animals. To turn into a dinosaur, you have to let Stompy bite you. I'm on my way. If I could be a dinosaur, what would I be? Great question. Oh, God, that's like asking what my favorite dinosaur is. It's, pick your favorite child. I don't know. I go through phases of what I'd want to be. I really like therizinosaurs. They're the long-necked Freddy Krueger hands dinosaurs. They got giant claws. I like to call them murder geese. They're really spooky looking. I like those a lot. I also do like the tyrannosaurs. I'm kind of a nerd for that. Aside from actual dinosaur bones, what is your favorite type of fossil to find? I think I kind of already said that. That would be mammal fossils. I got the opportunity to dig up the humerus of an animal called a hell pig in Teledonts. And if you look them up, that's an accurate description. They are terrifying looking. The species I got to participate in digging up was a species called Archaeotherium, which I also happen to have a cast skull of in my education collection here. But yeah, I love mammals. I love my dinosaurs. Like I said, they're the gateway. That's how I started in paleontology. But I love my mammals. Cats and elephants. Those are kind of my favorites here. Encephalization quotient. Yes, thank you for writing that out. What is the big skull I'm holding in the picture on, or I'm assuming on my website you're talking about? That is one of my favorite mammals, an American lion. It's a lot like an African lion, but American. No, really though, they're big. They were potentially the largest cats that ever lived. And they lived here in North America. We had them in Oregon and out where you guys are as well, and where the sanctuary is. They were a endemic species, and there were actually at one time 3 species of lions on the planet. We had the African lions; those were alive during the Ice Age. They were actually the smallest of the 3. Then you had the cave lion, Panthera spaela, which was the Eurasian species, and they would have crossed over into North America as well and been up in Alaska and Canada. And then going down south, you get that one, the American lion, which is Panthera atrox. And that thing was massive. It was built for chasing things down. It would have fought with the likes of things like the short-faced bear. Very, very awesome animals. I love them so much. An American lion's probably going to be my next tattoo, honestly. So Brontosaurus, maybe not smart. Probably not. I would wager that Brontosaurus is not a smart animal. Interesting. I like all these theories you guys are coming up. Did you ever read David Steed's Shark and Rays of Australian Seas? If so, what is your opinion on the fact that a marine biologist, thinks that his stories make the megalodon real? I have not read his book, but if he thinks the megalodon is real, still alive, then I got to talk to that guy. I got to break his heart. I'm sorry. Let's see. Do we know anything about dinosaur vision? Like, were their eyes fixed or mobile? Color or not color? Well, I can answer the color thing. They could definitely see in color because birds can see in color. In fact, mammals generally are the ones that cannot see in color. Birds and reptiles and all that can actually see in more colors than we can. Like the whole UV spectrum and stuff. I was learning that actually the other day. I have a bearded dragon here at my house. His name is Charizard. He was a Charmander when I first got him. I learned that if I were to take him outside, he would probably he'd see me as a completely different person because the UV rays from the sun would make me look different to him. But mammals see in black and white because of the way dinosaurs were kind of in charge of the planet. Because dinosaurs were big, terrifying monsters, the mammals were kind of relegated to being in the shadows. Which, I mean, that gets into the whole thing. Like, yes, dinosaurs did keep mammals small, but on the other hand, mammals kept dinosaurs big, which ended up being the winning card and the Cretaceous extinction, of course. But because of the being small and nocturnal, they lost their color vision so they could see better at night. And color vision kind of came back with primates as we started to, eat more fruit, and we needed to be able to see when the fruit were ripe. So most mammals don't see in color, but dinosaurs definitely could have. And T-Rex definitely could have seen you if you stopped moving. You're basically just sacrificing yourself to the T-Rex gods. Are there any parts of the world that had a particularly interesting or surprising mix of dinosaur species coexisting? Or was it pretty much the same everywhere? Good question. We already talked about the Hatzeg Island environments, the dwarf dinosaurs. That was a really interesting case. There's kind of a dividing line in the Cretaceous period where in the north you see animals. The main predators you have in the northern part of the planet are tyrannosaurs, T-Rex, Tarbosaurus. All the tyrannosaurs were in the north, and in the south you get the Carcharodontosaurs, Giganotosaurus, Mapusaurus, Carcharodontosaurus, and then mixed in there, a little smaller, you get the Abelisaurs, which were more southern. You didn't actually get too many Abelisaurs in the north, except for in Asia. I don't think we had any Abelisaurs in North America, but we seem to have Dromaeosaurs everywhere. Ceratopsians were strictly North American and Asian. We didn't get them in Africa or Australia or stuff like that. The planet, like a lot of at the beginning of the age of dinosaurs, a lot of the continents were still connected in Pangaea, but the splitting of Pangaea is what caused the Permian extinction, and Pangaea was still together, and so a lot of those animals kind of were the same. But yeah, there's a lot of interesting mixes. The other interesting one, this is a good segue back to that thing I forgot to talk about with Majungasaurus, the Abelisaur. In Madagascar, you see an interesting thing with the predators where there's neither tyrannosaurs or Carcharodontosaurs, the carnosaurs, and the top predator would be an Abelisaur, the Majungasaurus. So there is a gap where in North America, sauropods completely disappeared, went completely extinct, and then they came back towards the mid to end Cretaceous with things like Alamosaurus. But yeah, there's a lot of different species. Iguanodon has to do it for me. Oh, it keeps throwing me off. Do fossils ever hold partial? No. They don't hold DNA. Unfortunately, fossils of dinosaurs specifically the DNA's gone. We're not going to get Jurassic Park, single teardrop. My red flag is that if Jurassic Park were created, I would still go. But no, we're not going to get any dinosaur fossils. However, fossils from Pleistocene animals, we still have DNA in those because a lot of those are not fully fossils, right? You can go up into Alaska and just find mammoth bone lying on the ground. The tar pits are not true fossils, and so you can get DNA from those animals. That's how we learned that the dire wolf isn't actually a true wolf. It's its own species, right? So some fossils do, but dinosaurs, unfortunately, not so much. Oh, okay. I scrolled up. Dinosaurs like Pteranodon not being depicted with feathers and such. So that's one thing. I guess we're actually going to jump back to that general public thing. Pteranodon is not a dinosaur. Pteranodon is an archosaur. It's in the same big crown group as crocodiles and dinosaurs with the pterosaurs, but it is a pterosaur. It's a flying reptile. It's its own thing. In its own family with the Asdarchids and Dimorphodons and stuff like that. Not a dinosaur, but they are depicted with that hairy covering as well. They would have been warm. I believe the current understanding is that pterosaurs are warm-blooded. And with the skinny bodies that they have with the big membranes, they were going to need a coating of something to keep the body heat in. But they are now being depicted with hair-like structures on them, those pycnofibers. Let's see. Keep scrolling down. Hell pig. Looks like, oop, it jumped down again. Can you talk about coelacanth? I can talk about coelacanths. Coelacanth, there was a lot of different species of coelacanth, the lobe-finned fish, which out of all the fish, the lobe-finned fish are our closest ancestors in the fish line. But coelacanth, there was lots and lots of different species of them in the age of dinosaurs, And when the extinction happened, a lot of them disappeared and were just completely gone from the fossil record. And still, we don't have a whole lot of, we don't have any coelacanth fossils after the age of dinosaurs, and yet there are coelacanth living deep in the ocean today. How they survived, it's probably that specific line of coelacanth were deep sea animals, and the deep sea animals were able to just pass through the extinction without issue. But the ones that would have lived in rivers and estuaries and open oceans and stuff like that, they're gone, unfortunately. But yeah, coelacanth are still around, which is really cool. What would a Stompy equivalent dinosaur have for a diet? Stompy thinks his diet is air and hay. Probably the same thing. Looking at those Struthiomimus and the other ornithomimosaurs, they were omnivores. They kind of ate whatever they could get. Most of them had beaks. They didn't really have teeth. And so they were probably eating a lot of nuts and seeds and swallowing those whole, and gastroliths were crushing them up. But then they also had these terrifyingly sharp claws on their hands that were probably grabbing the odd lizard and whatnot. But they would have been prey animals themselves. Scrolling up, this might be off topic, but what food is Charizard's favorite? He likes cockroaches. I feed him dubia cockroaches. Bunny equals wolf enrichment. Oh no. I'm seeing all you guys react to the bunny now. Charizard is a good name. Thank you very much. All right, scrolling back down to the bottom. Sorry, don't know if you answered this already, but what's your favorite type of fossil aside from actual dinosaur bones? So yeah, okay. So type of fossil, I guess, is a little bit more of an easier question to answer, because I did say I do also love mammal fossils. I'm a mammal and dinosaur paleontologist, but specific fossils, I am a big fan of skulls. Just looking at all of the different varieties of skulls and how their teeth fit inside them and different shapes and learning how they're built and fit together. It's just I love skulls. And it's a bit of a problem because my company, the fossil team, I gotta get a lot of different bones to talk about, but I always end up buying the skulls because I love the skulls. Yeah, it's a problem. My room and office are very, very messy with dead animals. Do you think studying the animals that live near thermal vents would be a good window into living fossils? I do think that. A lot of those tube worms and stuff they aren't exactly the same species that were there in the age of dinosaurs or other prehistoric times, but tube worms like that were around. The deep sea, I do believe, if I'm remembering this correctly, I could be wrong, but if I'm remembering this correctly, the deep sea did tend to preserve a lot of those species, and that's why a lot of the ocean animals managed to make it through. Not the big ones, like the marine reptiles, like mosasaurs and plesiosaurs and such. All of those went extinct, but a lot of fish made it through. A lot of invertebrates and cephalopods made it through. So yeah, I do believe that is a good way to look at it. I think it's a good way to get a better understanding. I don't think it's a way to get the direct answers we're looking for, but it's a good way to lead into the right direction, right? I came in to someone saying their room is filled with dead animals. What in the world is going on? Yeah, that's fair. That's a fair thing. I got a lot of bones in my office, in my room. That's what we're talking about, as paleontologist, surveyor of the dead, I guess. What is one creature you wish we had a more complete skeleton of? Ooh. Oh man, there's a lot. I'd love to see a complete skeleton of that animal I was talking about earlier, the Belauer Bondoc, because that would tell us whether it was more of a dromaeosaur or not. Because right now we just have arms and legs of it, and the killing claws. We don't really have a skull of Belauer. And so the consensus on what it is tends to change all the time. I would also love to see a more complete skeleton of oh god, what was the animal? Just any of the big titanosaurs, the sauropods, because especially the titanosaurs, the sauropods are so big that most of the time the only bits we get are like a leg bone or a neck bone. I don't think we have really any skulls of the large titanosaurs, and so most of the reconstructions of titanosaurs we have are based on what we know of other sauropods. So I would love to see a more complete skeleton of a titanosaur, and I'm sure I'm not the only one who is thinking that. Are there any surviving prehistoric shark species? Well, sharks altogether have been around longer than the dinosaurs. However, all of the species that are alive today are not the same species that would have been alive millions of years ago. That is kind of a misconception about these fossil animals, right? Even that coelacanth we were just talking about. They are a different species, but their families survived, right? So the things like the what is it? I just lost my whole train of thought. I looked at the screen and I was looking for bunnies all of a sudden. My brain just like gave out. But yeah, sharks are great. I don't believe there's any species that were alive way back then that are alive today. I think they've all evolved into new species and changed and died out and such. No bunny, only big chicken. Yeah, welcome to Twitch. That's funny because this is actually my first real Twitch thing. I've never really done anything on it. So thank you for sharing this experience with me, everybody. Yeah, finding a giant skeleton would be awesome. Do we know if different species of dinosaurs were friendly with each other? You know, it's hard to say. Behavior is very rare. We don't find fossilized behavior a lot. And we do in some cases, right, with trackways and such, or like evidence of attacks on bones, right? Like there's this really cool fossil of an Edmontosaurus, one of the duck-billed dinosaurs, the hadrosaurs, with two of its vertebra in the tail fused together, and there's a T-Rex tooth in the middle, which would show a T-Rex attacked that animal, and the animal survived the attack and got away with a prize in a way. But one of the best ways to tell if an animal was friendly, saying it was like a herding animal, right, would be to find multiple specimens of that animal in one place, right? A really good example, bringing up Pachyrhinosaurus again, up in I believe it's a Canadian one, Dinosaur Provincial Park, I believe. There's hundreds and hundreds of Pachyrhinosaurs coming out together because it was a big herd that was caught in a flash flood. So ceratopsians might have been friendly to each other. We have evidence that T-Rex hunted in packs, but we don't have evidence that things like dromaeosaurs, like Velociraptor and Deinonychus, hunted in packs. All of those specimens are a single individual. So that would be the best way to answer that. And above that, have you ever been to the Chicxulub crater? No, but it's on my to-do list. It's on my my bucket list, my crater list. How does studying fossils benefit life today? That is a very deep question. Looking at how animals survived and how the world survived with different catastrophes and events and all that helps us better understand how the world today will respond to things. So take the ever looming threat of climate change as an example, right? The world is getting hotter and hotter and hotter, right? And the climate is changing, and ecosystems are being affected, and animals are being affected, and things are going extinct, right? A very similar thing happened at the end of the Permian. The Permian got so hot and so arid, and all of the the planet basically just like dried out and became a big desert. A lot of animals went extinct, and eventually the earth righted itself, and most of those animals were gone, but the ones that survived replenished the planet. And so as people, as humans, where we've placed ourselves in the planet as stewards of the land and such, we can look at fossils and see these catastrophes and what happened and make sure we don't do it. Now, that is, of course, assuming that people are going to listen to that, but we need to take the information of the past and apply it to the present. How can we do better and make sure that our species and other species continue to survive? That is kind of the problem. Oh, Shrudi's here. Hi, Shrudi. But yeah, so that's the benefit to studying fossils and understanding how we work and other animals work, and also just like getting better connected to the planet, man. Understanding our history and the world's history. It's a fascinating topic, and it is worthy of all the study that we can continue to give. Let's see, what else do we have? My favorite conspiracy theory is that human civilization restarted multiple times. That is a conspiracy theory for sure. Do you know anything about prehistoric bug species? I know very little. Like I said, I am a mammal and dinosaur paleontologist. That's where my focus and studies are in. And I have friends that are invertebrates. I have a good friend. You should look him up. He's very cool. His name's Cam Muscalini. He is a whiz with Georgia geology and invertebrates. He loves trilobites and ammonites and stuff like that. So he is somebody you should look into if you want to learn more about prehistoric invertebrates and bugs and stuff. However, I can't help you there. I'm lame and focus on things with fur and scales and feathers. Let's see, how many, do you have any good stories from fossil hunting? I'm picturing an Indiana Jones style adventure to save a rare fossil from the bad guys. Oh man, I wish. I do love Raiders of the Lost Ark. And Shruti can vouch for me, actually. There's a lot of people that were like, as we were growing up and working together in the zoo, it was very much like he's the Indiana Jones guy. But I do not have any fun, cool fossil stories like that, to my great chagrin. I would love to go save a fossil from a bad guy. But I do have this really cool experience, not necessarily with a fossil, but with a modern animal skull, because I work a lot with modern animals as well. Another friend of mine, and Trudy's actually, her name's Rachel. She works for the local parks and recreation district, and one of their visitors found this bear skull just kind of out in the woods, and didn't know how it died. That was very degraded. The skull was falling apart, and they brought it into the office there and turned it in. And the office didn't want to fix it up. They didn't have anything to do with it, and they were like, you know what, let's donate it somewhere. And they asked if I wanted it, and I'm kind of big with only having one specimen, because I've got limited space, of course, but also, like, if I've got the one specimen that's good, I want to make sure that that animal gets respected and used as an ambassador, and then the other animals that come my way can either go to other places and all that. So I took it to fix it up and clean it up, right? And I had the wonderful opportunity of putting this black bear skull back together, and it ended up showing some really interesting features. It had a little bit more of a sloping forehead than most black bears do. It almost looked grizzly-like, but we don't have grizzlies out here in Oregon. And also with its teeth, the incisors specifically, that's the front teeth, it had an extra tooth in the middle, so it had an odd number of teeth. It had this weird deformity with the teeth, and it's very interesting skull. And I put it back together, and then it kind of just sat in my archives for a little bit, making sure so I could find it a good home. And there was a point later on, I was hanging out with this other paleontologist by the name of Dr. Darren Naish. He came out to Oregon, and he's actually the lead scientific advisor behind Prehistoric Planet, that show I was just talking about. And I was kind of showing him around Oregon, and we went to this local place, this local museum called OMSI, the Oregon Museum of Science and Industry, and they have a little paleo lab with volunteers and stuff, some good friends there. And I brought them there to go show them because they were working on these fossils that they had found of not a new species, but a recently redescribed species called the spiked-toothed salmon. And some of the best fossils of this animal ever found were at the Museum of Science and Industry, or at OMSI. And so I took Darren there, and while Darren was looking at these fossils, I started just kind of wandering, and I looked at their bear skulls, because they had a bunch of modern animal bones as well, and they had a skull labeled as black bear. But then I was looking at it, and I was like, that's not a black bear, that's a panda. And it was a cast of a panda skull, and I pointed it out to my buddy, and he goes, "Are you sure? I got it. When I bought it, it said black bear." And I said, "No, that's a panda." And Darren, he looked at it, and he goes, "Yeah, that's definitely a panda." And my friend, he was like, "Oh shoot, that sucks." And I was like, "Well, how about this? I've got a black bear skull that needs a home. I'd love to donate it to OMSI." And so I got to fix up this black bear skull and rehome it with another museum. So that's a fun story that I have. I do love that story. Let's see. It seems like there's always contradictions over the cause of extinction events. How do we figure out the exact causes of them? Do we know what caused any of the individual extinction events, or is it all speculation with multiple possible explanations? That's a cool question, because everybody's looking for the smoking gun with all of these questions, or with all these extinctions, right? What killed the mammoths and saber-toothed cats? What killed the dinosaurs, right? And without, massive amounts of evidence, we really can't say. And so in some cases, like I believe the extinction at the end of the Triassic, we don't really know what killed off most of the. I mean, we suspect it was the inability to deal with the climate, but we don't know what killed off all those Rawasuchians and the last of the Dicynodonts. I never brought them up. Things like Placerius and Lysawecia and Lystrosaurus. But in other cases, we do know exactly what did it. Like in the case of the dinosaurs, we know for a fact a meteor caused the extinction. Did the meteor itself kill all the dinosaurs? Absolutely not. The meteor started the extinction, right? The meteor or asteroid hit the planet, and if you look at the boundaries in the rock layer, you got the Cretaceous boundary, then there's this thick black iridium layer. And iridium is a very rare mineral on Earth, but it is very common in asteroids. And, after the iridium layer, you have the Paleocene, where Titanoboa is. And, Cretaceous, you have dinosaurs, and Paleocene, you don't. The dinosaurs are gone. And so it's pretty evident that the meteor was the thing that caused it, right? And there's all these debates on, like, was the dinosaur population already declining before the meteor hit? And current studies say no, it doesn't. But it was actually more what the meteor caused that made the dinosaurs go extinct. The biblical event, almost, of like the blotting out of the sun, the changing of the temperatures, everything. And so it's never one thing with an extinction. There's always multiple factors, especially with mass extinctions, right? With the smaller scale extinctions, like you look at the one at the end of the Ice Age, the Pleistocene, that one was pretty clearly caused by people, right? But that's technically not a mass extinction, right? A lot of the animals from the Pleistocene are still alive today. It's mainly the megafauna that were hit hard, and then the smaller species that went extinct were animals that were specialized to work with specific megafauna. And so there is always going to be debate in science, and that's kind of the beautiful thing about science is like it's all theory, and a lot of it can be pretty sound theory, but it's still theory. Unless you were there, you don't know, and we weren't there to see the dinosaurs get punched in the face with an asteroid. Dinosaurs had that Tom Cruise smile. Oh, that's good. Nico, thoughts on transitions from jaws to teeth to beaks? A lot of dinosaurs had, or birds even, had beaks with teeth. It depends on what they were eating. And the family that birds are today, the one family that survived the extinction, there used to be 3 different families of birds, and now and 2 of them are extinct, and now all the birds have common ancestors today. That specific family happened to not have teeth. And so it all depends on what they were eating, right? And today, none of the birds have teeth, even though a lot of those birds are filling niches that those other birds would have that did have teeth. It would appear that the teeth in those niches aren't necessarily necessary. They helped those animals when they had them, but the teeth obviously didn't come back, right? So they weren't necessary. They were just a little bit more of an advantage, right? And so the teeth, the transition was gradual, and there were dinosaurs that even had beaks and teeth. Like think of the ceratopsians; they had beaks in the front and teeth in the back, right? So it really just depends on what the animals are eating. Let's see, meteor like that drink you have on the night that starts the swift decline. Let's see. I'm catching up on the chat. Excuse me. Did they go extinct or get mass abducted? We're getting into the conspiracy theories again. Yeah, look at that. Did I miss anybody's questions? We were moving so fast in chat that I'm hoping I didn't miss anybody's questions. If there was a question that somebody asked, you want to make sure it gets answered, please re-enter it. I am scrolling up to make sure, but oh, here's one that I missed. What is your favorite age in terms of the type of flora and fauna? Ooh. I've been asked before if I could go back in time, where would I go? And I'd honestly probably go to the Pleistocene. The Pleistocene is kind of where my heart and joy is. Hence the American lions and mammoths and stuff like that, saber-toothed cats, Smilodon, and just to see what some of those animals really would look like, and if take a woolly mammoth for example. Would a woolly mammoth act like an elephant, or would it act different? I want to know. I want to know. Did American lions have manes? Where the kind of the question, or the current thought is that they didn't. But did they? Because they are lions. What did a saber-toothed cat look like? There's one petroglyph of a saber-toothed cat in existence, and it's in Arizona, and it's the only one ever found of a saber-toothed cat, and it seems to have spots, kind of like a bobcat. I'd love to see if that was the case. It all comes down to the ferns for you personally. That's fair. What is the most exciting new discovery you've heard of recently? We kind of talked about that with the Archaeopteryx thing, which was really cool. There was a recent paper just came out. Actually, speaking of lions and the American lion, there was a recent paper that just came out that was talking about the gradual decline in size for the cave lion, which was really interesting. Like, why were they getting smaller? And it's probably because the cave lion was competing with dire wolves and such, and the gray wolf, but we don't know for sure. I'd have to read that paper again, but it seems like they just kind of kept getting smaller and smaller. There was another paper actually about lions. I haven't read it yet, but a friend of mine went to a conference, and this person gave this whole presentation on the lions at La Brea. And the interesting thing is, if you look at the environment where American lions come from, it's a lot like the environment that African lions live. It's very grassland. It's very like what you imagine classic Africa like. Great Plains, except instead of Cape buffalo, you've got bison, right? And instead of zebras, you've got American horses and stuff, right? And instead of African elephants, you've got Colombian mammoths and woolly mammoths. But the lions in La Brea was a different kind of environment before, there were cities and concrete over it. And it would have been more shrubland. It would have been more woodland and stuff like that. Coast range. And so these open grasslands weren't necessarily there. And if you look, the La Brea tar pits show this really interesting dynamic where you have more predator fossils coming out than prey fossils. And the reason for that is that the tar pits are kind of a predator trap. An animal will get stuck in the tar, like say a mammoth or a sloth or a horse, and it doesn't die right away. It gets stuck, and when it's stuck, it calls out. It's trying to get out. It's making a ruckus, and that attracts the attention of the predators. And the predators from all around come in, and then they eventually get stuck as well, trying to get the free food. And we have all sorts of animals coming out of, or predator animals coming out of the La Brea tar pit. Short-faced bears, black bears even, pumas and lions and saber-toothed cats and dire wolves, which are the famous one out of the La Brea tar pits. And the thing you see clearly is that the dire wolf is the most common animal coming out of there. So what that tells us is that the dire wolf was a highly social animal. It had very large packs and were hunting big prey, right? And then after that would be the saber-tooth, Smilodon fatalis. That is the second most common predator coming out of the tar pits. And with that, we see that Smilodon was probably living in small groups as well, small prides like lions. However, the American lion, there's not very many of them coming out, which shows that they were more solitary, at least in the La Brea environment. And so what this paper with the scientist, I'm blanking on her name, unfortunately, but what she was saying was that the lions in the La Brea environment functioned more like large tigers rather than lions, and was kind of hinting at calling them American tigers instead of American lions, which is also just as cool to think about, in my opinion. Let's see. Catching up on questions. In case it wasn't answered, is DNA sequencing genomics used more frequently now in the field of paleontology? You see being used more in research now or in the future? The genome stuff is definitely more important now, especially with these early or these later fossils of mammals and stuff, because we can get a better understanding of where they fit in the evolutionary tree. And that's how we came to the conclusion of, like we said it earlier with that other question that kind of asked the same thing but didn't, with like the dire wolf not truly being a wolf, but it's still a canid, but it's not a wolf. It's its own thing. Aniscion, not Canis. And on top of that, we get these whole new families, and we find out where animals today are fitting, right? So like we can really break down most mammals into three groups today. You've got the Eurasiathere, which would be most everything. And then you've got Xenarthrans, which are armadillos, anteaters, and sloths. Those are your South American animals. And then you've got Afrotheres, which are elephants and hyrax and Sirenians, which would be like sea cows and dugongs and manatees, and aardvarks and I believe pangolin. No, I was asked this by one of my students the other day, actually. Where do pangolins fit? And I believe they're either Afrothere or Eurasiathere, but at least with placental mammals. Marsupials don't fit into one of those three groups. Marsupials are part of a different group of mammals called the Metatherians. Whereas, Afrotheres and Eurasiatheres and all that, they're Eutherians, the placental mammals. And a lot of those lines were not figured out until genomic studying happened, right? We're not going to be able to do that with dinosaurs. We can't get DNA from dinosaurs, unfortunately. We're going off of best guesses and current theories and understandings of bone structures and stuff like that, right? So yeah, thank you. La Brea Tar Pits is a bucket list place for me. Yeah, me too. Actually, I gotta get down there still. I study it, but I haven't been down there. Gotta run. Oh, thanks. Sharp and easy. What's a puma? Mountain lion, cougar, catamount, screamer. Lots of different names for cougars. I do love me a good mountain lion. What sort of sizes are these predators? Well, dire wolves are not too much taller than gray wolves, unlike Game of Thrones would suggest, but they are a lot bulkier. They're a lot buffer than gray wolves. Lion, the American lion, is a good half a foot to a foot taller than the African lion. The lions I've worked with, like at the Oregon Zoo, the big male Zawadi came up to about, I believe, a little under my chest. But the American lion would be a good shoulder height. They were big. They were real big. You could ride those things. And then, of course, there's the short-faced bear, which, when rearing up on its hind legs, was about 12 feet tall, maybe a little more. They were giant bears. So big. A lot of these predators are big. To answer that question. Let's see. Thanks for talking, mysterious paleontologist voice. I'm still catching up. This is great. How has recent 3D scanning technology and AI affected paleontology? Has it helped categorize and make connections between families and known species? 3D scanning has been an excellent tool in paleontology, because not only does it make fossils more available for people around the world, but it can help get better understandings of different parts. So like, instead of saying like, hey, I found this, we'll say sloth, right? I found this sloth species here in North America, but we don't have a sloth paleontologist on deck, so we need to send this sloth to people in La Brea or South America. This fossil, right? In the past, they'd have to send the actual fossil, and there's the potential of losing it. There's the potential of damaging it, and that one-of-a-kind thing being lost forever. However, with 3D scanning, we can say like, hey, we found this thing. I scanned it. I'm going to email it to you. Can you let me know what you think? And then 5 minutes later, you got an answer. That is the best part about the 3D scanning. AI, no help. AI is no. I personally do not like AI. I think it is damaging a lot of the science, and there's a lot of papers that are now no longer hiring people like my buddy who's a paleo artist to help describe the animals that are being talked about in papers, and instead they're making some AI monstrosity picture to accompany the paper that doesn't even describe the animal they're talking about. It's awful. So no to AI, yes to 3D scanning. Are animals still getting fossilized today? Oh man, we've been going for a while. We'll wrap up here soon, but let's see. Yes and no. Fossilization takes a really, really long time and very specific circumstances, right? So the animal can't, it's not just burying an animal. Burying an animal is not going to fossilize the thing. It has to be buried in the right place at the right time with the right heat, right pressure, right everything, right? So there's potential that an animal could fall into a place or die and get buried under, sediments in a river or whatnot. But it's not happening quickly. It takes hundreds of thousands of years to truly fossilize a bone. Are you a professor at a university or a teacher in a school? I run my own company called the Fossil Team, which is the website that keeps being brought up. But the company, I work with other schools and universities and museums and talk about dinosaurs and mammals and all sorts of things. And so people will hire me and I will go out with all my fossils and bones and educate the public. Like for example, this festival I keep talking about this weekend. I was hired to go talk about dinosaurs in a lecture and set up my booth and talk about skulls and stuff. I'll be bringing like the short-faced bear and an American lion and stuff, but also like a woolly rhino and T-Rex and stuff. So it's going to be a lot of fun. Would you guys ever get a capybara? Is that a question for me or the sanctuary? I would love a capybara, live or dead. I think it'd be great. Let's see. I'm still catching up. Why is Shruti the coolest coworker you had? Because that is a tough question. Because she's rocks. Like, she's awesome. Like, fun working with her and fun hanging out with her and being friends and stuff. So like, yeah, there you go. Answer that question. Let's see. AI does have scary potentials. AI in paper is so tragic. Also takes it just takes the humanity out of it, like if you're really into it and if you want to write a paper, don't make a robot do it for you. Put some heart and soul into it. Most of the time papers are being published is because people really believe the theories that are behind it, A computer is just going to spit out some words. Sorry, I'm still catching up. Okay. I think I've caught up. Justice for Science illustrators. Yeah, absolutely. Look at all the Ghost Shrutis. Awesome. What's your best bone pun? I think you kind of know the answer to that one. Yeah. All right. Yeah, let's start wrapping it up. I think we've been, some of you guys probably need to go to bed, I think. I don't know what time it is where you're at. But yeah, thank you so much, everybody, for inviting me on and having me and hopefully we'll get to do this again. Or, if you want to keep going, go to my classes on my website, fossilteam.com, or follow me on Instagram or whatnot. I do Fossil Fridays and stuff, and that'd be the Fossil Team PDX. And yeah, thank you so much. And until next time, I guess I'll end my chat here. Bye bye.